Okay, my name is Maria Vaughn, and I'm doing a lab on chromatography and food dyes for Chemistry 2, Professor Pishva. This experiment allows students to understand and witness how various chemical solutions can be separated in order to conclude which food dyes appear in certain foods. It will ultimately show students how these particular mixtures can be separated. The separation of these solutions is dependent on the size and polarity of each compound. For this experiment, I hypothesized that the blue dye will travel at a quicker rate than the other colors. Most of the dyes used in this experiment will be polar and have great solubility when exposed to water. The more polar of the solutions will be absorbed more readily, but the salted water paper thereby allowing to define slower moving solutions to be more polar. We add a pinch of salt into 50 milliliters of warm water. Use 2 pieces of filter paper from the lab pack and draw a line across the bottom of the paper. This line should be faint in appearance. From the draw line, draw 9 lines vertically across the previously mentioned line. For each color of dye that is to be tested, place a few drops in the 24 well plate. After that, dip a toothpick into the dye and place it on one of the marked paper. For the marked paper, into the cylinder so that the edges simply touch but do not overlap each other, and hold it together with the use of a stapler. After this, we covered the bottom of the petri dish with salt water to the depth of approximately ½ centimeter. We then place the dye cylinder into the eluting chamber. We quickly witness the solvent moving up along the paper. From here, the data gathered would be recorded. Attached in our lab is the additional data tables, but from this experiment it can be concluded that a pencil versus a pen should be used to draw the baseline of the chromatography paper, because the ink from the pen will bleed, affecting the accuracy of the experiment. It is also important to stop the chromatography before the solvent reaches the top of the paper, because it will cause the compound to diffuse. In this experiment, it should also be noted that we keep the dye spots about the solvent levels below the solvent levels, because it will help eliminate evaporation and the spots will run off. Practical applications. Chromatography is used to purify desired components of a complex mixture. As in the pharmaceutical industry, so that safe and highly effective products result. It is also as a diagnostic and analytical tool by doctors, scientists, and forensic technicians. Our observations were that for the blue one, we had a distance of 45 millimeters, and an RF of 1. Blue 2 was 20 millimeters, and 0.44 RF. Red 3, 7 millimeters, 0.16. Red 40, 15 millimeters, 0.33. 15 millimeters, 0.33 for yellow 5, and the same for yellow 6. The solvent was 45 millimeters. For data table sheet drink mixes, for the Kool-Aid, we had a grape, we had a distance of 33 millimeters and an RF of 0.89. For Kool-Aid strawberry, we had 11 millimeters and an RF of 0.29. The solvent was at 38 millimeters. For store red, for the food colors, we had a distance of 9 millimeters and 0.18 RF. Store yellow, 20 millimeters, 0.4 RF. Store green, 45 millimeters, 0.9 RF. Store blue, 50 millimeters and 1 RF, and the solvent at 50 millimeters. For candy colors, we had a distance for M&M green, 45 millimeters, RF 0.9. For M&M yellow, we had 20 millimeters, RF 0.4. M&M blue distance was 50 millimeters, RF 1. M&M red was a distance of 50 millimeters, RF 1. And solvent was 50 millimeters. We concluded that it is important to mark the solvent level on the chromatography paper when you remove it from the petri dish, so that you can measure how far it travels. It's important to keep the dye spots above the solvent level to eliminate evaporation, and the spots will run off. It is important to stop the chromatograph before the solvent reaches the top of the paper because it will cause the compound to diffuse. And we do not use a pen to draw the baseline of the chromatography paper because the ink will bleed, affecting the color and distance.